Um, Good evening, everyone. My name is Ismail Makhlouf. I'm a data analytics architect at AWS. I'm very sorry that this is the last session and I'm keeping you from the coffee outside, so I hope it will be useful and entertaining for you. Everybody this morning has been talking to you about how do you get your applications and your data to AWS, how do you secure it, how do you get your SAP workloads up there, what are the best practices for using it, how have others done it before. Now that your data is in the cloud, what I'm going to be talking to you about today is what do you actually do with it? How do you move it around? How do you make use of it for your business? So first I want to start by talking about the trends that we're seeing across the world that are making the changes in the data world challenging to overcome. The first trend is the explosion of data. There is way more data than ever before. The second is explosion of personas. There are many, many different people and stakeholders that you have to manage now that want access to the data and they want to be able to analyze it themselves. And the third is demand for faster decision-making on data. It's not acceptable anymore for us to wait so long for data to take action on top of. Now you need things to happen on the seconds or even milliseconds of time frames, depending on the use case that you're looking at. So let's talk about the explosion of data for a second. The amount of data that will be created, consumed, and stored in the next 3 years is around 448 zettabytes. Now, I'm sure some of you who are in the data world have seen some version of this slide in the last 3 or 5 years, and the number keeps changing. Hopefully, this is the most updated one. The problem with this number, though, is it's so huge that it's hard to visualize. So to put it in context, what does 448 zettabytes actually mean? It means if you took the Eiffel Tower and you stacked 1 terabyte hard drives all the way to the top, 20 million times, that would be the amount of data that equals 448 zettabytes. Another way to think about it is the length of the Earth, the diameter of the Earth, 527 times of 1 terabyte hard disks. That's how large this number actually is. So it's an unprecedented amount of data. The second is an explosion of personas. So right now, you don't just send data to a business stakeholder or send it to IT and they make a couple of dashboards. Now you have data analysts that need tools, you have data engineers that need to perform sophisticated analysis, you have business analysts, you have line of business, people from finance, people from supply chain, people from operations. All of them want to get their hands on the data and do their own thing with it. Then, of course, you have your executive, your C-suite, who want the summary of everything across the whole organization rolled up to them to the level of granularity that will allow them to make the big strategic decisions. And then you've got third-party partners that you're working with. A lot of data sharing agreements are happening now, especially with the growth of fintechs and especially the fintech ecosystem in Egypt. How do you share data securely with third-party partners in such a way as that they can make use of the data in a repeatable fashion without you having to waste time building reports over and over again? Regulators and auditors. If you're working with the Central Bank of Egypt or any other financial institution, or you're in a regulated industry like healthcare, you're always going to have regulatory reporting requirements. That's a totally different use case than other types of users that we mentioned earlier here. And then finally, your customers. If you're building dashboards for your customers inside their portal, for example, and it's something you're offering as a service, they have a totally different set of requirements as well. So whatever you do now, you need some way to address all of these different types of users. The third trend, as we mentioned, is faster decision making. Data has a shelf life. Speed is important. If you have some kind of transaction that happened on your system and that transaction is fraudulent, you can't wait a whole day for a batch process to happen that showed you that transaction is fraudulent. You need to take action now. If you have some kind of new users coming in that you acquired through expensive marketing dollars, they've landed on your website. You've only got a couple of seconds to capture the interest, offer them something personalized, and have them convert onto your website to become a customer. All of these things, the longer you wait, the lower the value of the data becomes, and the more money you left on the table. So it's super important to be able to manage real-time data quickly. So To be able to address all of these trends, the aspiration that we've seen across the world is to become a data-driven organization, right? Now, what does that actually mean? By our definition, it means three things. Number one is that data is an organizational asset. It doesn't belong to IT, it doesn't belong to HR, it doesn't belong to any specific person or department. It belongs to the organization, and it's something that everybody in the organization can use. The second is that it's democratized. So different users that have a legitimate need for that data can access it across the organization or maybe even outside of it so that they can make use of it. And the third is that the data is actually put to work. If you have lots of data sitting in your databases or your data warehouse, but you're not using it, you're not actually reaping the business benefit from it. So the third thing is to actually put it to work. Use it in analytics and in machine learning to make better decisions, to create efficiencies, to drive innovation, to drive agility, etc. So that's what we mean when we say becoming a data-driven organization. Now, this has real business outcomes. We're talking from a Forbes study that was conducted across a couple of organizations, an average of a 415% ROI across 5 years from the organizations that have undertaken that journey. I'm happy to share the details of that report offline, of course. So a lot of you already know this, and I'm sure that you've started this journey, and 85% of businesses actually want to be data-driven, but only 37% have actually been successful. So what we want to talk about for the rest of the presentation here is what can we do to become one of these 37%? Well, it starts with really building a modern data strategy, right? You need a strategy so that you can become data-driven. And that data strategy has a couple of business outcomes that need to be in place. The first is whatever strategy is in place needs to help you make better and faster decisions. The second, you need to be able to improve customer experience and loyalty, reduce churn rate, reduce customer acquisition cost, improve your CX and CSAT and NPS scores. The third would be to stay ahead of the competition. You saw what the panelists were saying earlier today. Some of them even differentiate their product by providing customized dashboards for their customers, like TAS Technologies, for example, so that they can use that as a competitive edge. But even if you don't offer data as a product, within your internal processes, you can still leverage data for insights that your competitors wouldn't be able to do if they're not data-driven, and that will be able to give you insights that will keep you ahead of your competition. The fourth is to be future-proof. You need to be able to have systems that will weather the storm. You need to build your data strategy and your data organization so that it can be ready for whatever comes, no matter the different types of data that will arise, no matter how big the data gets, no matter how fast it gets. You need to have a strategy that won't be surprised when the future comes. And the fifth, of course, it's very important to still manage your bottom line, manage your processes, make sure that you're running in the most efficient way possible. And you can't fix what you can't measure. And data is all about measuring the right thing so that you can take the right action. So with these things in mind, we at AWS have built 5 modern data strategy pillars to help you achieve those outcomes. Number one, scalable data lakes, and we'll talk about that in a second. Second, purpose-built tools, so having the right tool for the right job at the right time, for the right use case. The third is to have things that are serverless and easy to use. The fourth is taking all of these things and underpinning them with the right data governance, data access, and security. In addition, and integration with what Kamran was talking to you guys earlier about. And the fifth is to embed machine learning within whatever tools that you're using so that it can give you back faster results and better insights. So let's talk about data lakes for a second. Now, if some of you have been working in data analytics for a while, you will be very comfortable with loading data into your data warehouse. And this is something a lot of us have been doing for 20 and 30 years, and it works very well for its assigned use case. But if you're moving across from the CRM and ERP world into devices and social and clickstream data and unstructured data and text, it's not the right tool for the job. What you need is a data lake where you land all that data and then you take a subset of it in the data warehouse designed for what the data warehouse is for, which is to serve business intelligence workloads downstream. There are many benefits of looking at the data lake as the center of your data estate. Number one is to be able to store all your data in open formats. In the old world, you'd load your data into the database and you have to go through that database to access the data. So you have to use that vendor's technology and their formats and their language to be able to manipulate your data. That's not the world that we live in anymore. Store all your data in open formats. Store it in Parquet, store it in JSON, store it in Avro, and then use whatever tool that you want, whoever is comfortable with accessing the data with the tools that they want, and have all of those open formats that can interoperate with these different technologies. The second is you need to be able to store structured and unstructured data at scale. You saw earlier there were some demos about machine learning, right? So what kind of data is inputted there? Images, text, labels, crumpled up receipts. How are you going to store this in a database? It doesn't really work. So you keep all your structured and your unstructured data here in your data lake. And since it's in the data lake, which is not tied to any analytics tool, you get to decouple your storage for compute. This is very valuable because if you have to put everything on disk, you have to keep increasing your CPU just because you need more storage. And as you know, CPU is very, very expensive. So to save cost and to be more agile and to use different types of compute, just decouple them. So the data lake scales the storage, and then you use whatever you compute you need just to analyze the data that you want from that subset of the data in the lake. The fourth is to be able to process data in place, so you don't have to keep loading the data and multiple copies of it into different tools. You can send the compute to the data lake, perform the query, get the data back, that's it, you're done. The fifth benefit of having a data lake is that it's flexible enough to be able to serve all of your analytics use cases. So if your data is there, you can really use it to serve data warehousing, you can use it to serve big data, you can use it for interactive querying and ad hoc data exploration. If you have massive amounts of logs, you can use it for operational analytics, you can use it to serve your visualization layer, etc., etc. The point is, for your analytics needs in general, you keep the storage in the lake, and then you just use the compute on top of it in and out in different parts of the lake, depending on what your users need. So we talked about data lakes. Now we're going to talk about having tools that are purpose-built and why that is important. In general, what we've seen is that professionals use purpose-built tools. You wouldn't use a hammer to remove a screw. You use it to hammer a nail. And when you use the right tool for the right job, you can get your work done faster with higher quality and more cost effectiveness. And AWS has the broadest and most cost-effective set of different analytics services for different use cases. So we've got Athena for interactive querying, EMR for big data processing, and we will be going through the rest of the list. So we said that the data lake should be the place where you land your data, and then you can serve different use cases. So once the data is there, what are you going to do? First thing, you want to query it, right? You want to figure out, okay, what's in the data? What does it look like? Can I profile it? What data is this the data that I need? That's what you would use Amazon Athena for. Just send SQL queries to your data lake, get the data back. That's it. No complicated setup, no infrastructure provisioning, no complex database to acquire. You just send SQL queries, you get the queries back, you have an idea of what's happening inside. Now, once you start knowing, okay, now I have lots of data coming in, I know what I want to do with it, I need to run it on a continuous basis, and I have big data workloads on premise that I want to scale out. This is where Amazon EMR comes into play. It stands for Elastic Map Reduce. And what EMR is our proprietary managed open source service. So here is where you can run your Spark, Hive, Presto, HBase, or Flink workloads. So if you've gone through the pain of setting up big data on premise, this is its home in the cloud. Move it there, and the underlying infrastructure management becomes our problem to deal with, and you can still focus on building your big data applications. We update the latest frameworks within 30 days. There's support for frameworks like Flink and Hoodie. The performance, which we continue to improve, is around 2.x faster than open source vanilla Spark, etc. The main point here is you can get the best of both worlds. You offload the infrastructure management to us, but you can still get the cost savings of the cloud with reserved instances and using EC2 spot instances as well. And you can scale it out as much as you need, as we've mentioned earlier today and many times in many sessions. Now, say that you don't really have a need for Cloudera or Hadoop, but you do want to perform ETL and you want to start from scratch and you want something that's easy to use and it is manageable. This is where you'd use AWS Glue. AWS Glue is a data movement service within AWS. So you use this for data integration. It's got built-in data transforms. There's an underlying Spark execution engine, which you don't have to manage, but you still get to use its firepower so that you can execute your ELT and ETL workloads. And it's integrated with our monitoring stack as well. So if you've seen the other presentations that talk about CloudWatch and other monitoring tools as well, it's integrated with them so you can follow along and see how your jobs are performing. The second part of Glue is data governance. So there is something that we have called Glue Data Catalog. Now, if you have a data lake and it becomes unmanageable, we call that a data swamp, right? Going with the analogy. To avoid having a data swamp, you need to be able to manage your data assets well. And that's where a data catalog comes in. You need a place where you can actually find the data that you have in this huge lake. So with Glue Data Catalog, you can tag your data assets and its schema and its metadata and watch it as it evolves. And that's integrated with the rest of the AWS analytics services as well. So you have logical tables and logical databases as a construct within this catalog that you can interface with. Closely related is the AWS Glue crawler, which is the tool that goes and crawls the data from the source, gets the metadata, and sends it to the catalog. And the third part is Lake Formation, which we'll talk about later, but it is a data governance tool that allows you to choose who am I going to share the data with? Which parts of your data are you going to share with which users? Very important for governance. We have a range of connectors that you can use. Obviously, you will have a lot of data sources in your systems, CRM, ERP, third-party APIs, data that you want to connect with, other S3 buckets, other clouds. Glue has a lot of connectors that you can use out of the box. And if we don't have it in AWS, we have a whole marketplace of connectors as well. If you're familiar with companies like CData, for example, they specialize in making connectors that nobody else makes, and you can just grab that off of the marketplace and use it. We've got a variety of interfaces as well, again, because of the explosion of personas, 4 different types of users, the low-code, no-code style, and the high-code, high customization style for data engineers, etc. So if you look at the main 2 personas that Glue targets, on the left, you've got the ETL developer. He or she would use something like Glue Studio, where you can author the ETL jobs without writing code, but then you can open them up and dive deep into the Python or SQL scripts and perform advanced code transforms as flexible as you'd like to make them. On the other hand, if you have somebody like a data analyst or a power user from like within the finance department who wants to get their hands on the data and they want to do it themselves but they don't have coding experience, that's what you would use Glue Data Brew for. Glue Data Brew allows you to do things like profiling data, getting the min-max, getting a distribution of the data set, being able to clean and normalize and apply data quality rules, changing things from lowercase to title case, splitting addresses, removing invalid characters, all of these different types of operations. We've got maybe 250 of them out of the box that people who don't know how to write code can use. And you can do things like map data lineage and automate those cleaning and profiling jobs and have it as part of your data analytics pipeline end to end, just like you would with your regular analytics tools that are code-based. Now, we talked about EMR and Glue, and they're great at what they're used for, which is mainly batch processing. But we also said that one of the trends that we're seeing is that you need to action data fast. So you need to have the tools necessary to be able to analyze data in real time. That's where MSK and Kinesis come in. So if you're familiar, Kafka is one of the most popular stream processing frameworks in the world. And to give you the benefit of using Kafka without having to manage the infrastructure, we've developed Amazon Managed Streaming for Kafka, which is highly available, highly secure, integrated with the rest of our security stack, and it is a managed service. Now, what do we say when we mean managed service exactly? Hopefully this will give you an idea of how managed we're talking about. Now, on the left here, you'll see that if you try to do this on premise, this is what you have to deal with. You have to take care of HVAC, hardware lifecycle, hardware maintenance, version upgrades, etc., etc. If you move to EC2, you wouldn't have to deal with the hardware issues, but you still have to patch the operating system. You have to deal with the data transfer cost. You have to deal with actually managing Kafka, managing your Zookeeper nodes, managing scalability and availability. With MSK, you don't manage any of this stuff. You just focus on your MSK cluster, right? To the level of tuning your brokers and your nodes, but that's it. All of this other stuff here, we manage it as AWS. So if you like Kafka, if you want to benefit from it, again, you can get the best of both worlds here with a managed open source solution like MSK. However, again, if you don't necessarily need Kafka or you want to just get started with real-time streaming, you can use the Kinesis family of products, of services. So you can use Kinesis Data Firehose as a stream delivery method to deliver data to your data stores. You can use Kinesis Data Streams, which would be the equivalent of MSK for stream storage. And you can use Kinesis Data Analytics for actual analysis. So this is like the equivalent of an ETL tool, but in the real-time streaming world. So you would be doing SQL on a window of time, on the fly, right? There's no start and end time for the batch, right? It's a continuous stream. So you just take a snapshot of that window as it moves in time, and you produce insights that you're going to give to your business users. Like, let's say we wanted to give an operations manager the amount of packages that have been shipped out of the warehouse for the last 5 minutes all day. This is the kind of thing that you would use real-time processing for, and you would use Kinesis Data Analytics for. Now, we've done the heavy lifting of querying the data, we've done our batch workloads, we've got our real-time data streamed into our data lake. Now we actually want to start building dashboards, and that's when we would load it into our data warehouse as we've been doing before. And that's where Amazon Redshift comes in. Amazon Redshift is actually the first cloud data warehouse that has been developed. And we've developed new hardware and new architecture for it as well, so it's 3 times faster than before with our new RA3 nodes. And we've added hardware acceleration as well, so we've built custom hardware specifically to maximize the use of Redshift's massively parallel processing architecture, as well as we integrated very well with the data lake and other analytics tools. So one way you can save a lot of time and a lot of money is not to bring data into the data warehouse at all. So there are cases where Redshift is integrated with the lake and you just send compute to the lake and bring the result from the query and join it with the data in the data warehouse. We have different variations of that are integrated with Redshift. Price performance, of course, and it is up to 75% less than other comparable cloud data warehouses, and the pricing model is also very predictable, helping you manage your costs, where usually the data warehouse cost is a big item on your bill. This will help you manage the predictability and cost effectiveness of it as well. So the last step that we would need to look at here is actually visualizing the data, some kind of tool, so that we can take decisions on our based on the insights that we're seeing. That is where you can use Amazon QuickSight. So QuickSight is our BI tool, and it is something that uses the scale of AWS to scale out to tens of thousands of users very, very quickly. It is serverless, so you don't need to worry about provisioning any infrastructure. You just create dashboards in minutes and deploy it wherever you want around the world. It is integrated with our different AWS services, so managing connections and security between them is also quite easy. We've also added API support, so for your back-end engineers who are managing your BI environment, they can onboard users, they can manage content, and you can embed dashboards into your applications as well. So again, if you're building your data as a product, you can use QuickSight to put that into your application and serve that to your users. Another important call-out is the ML features that are inside QuickSight. So there are different features that you can use while you're building your dashboard. So one of them would be anomaly detection. If you detect an outlier or errant behavior, you can just embed or call the anomaly detection feature within QuickSight. Forecasting, you don't need to go out and call a separate forecasting model and then send it back to QuickSight. You can forecast from within QuickSight itself. And you can use machine learning predictions. So the middle layer that Muhammad Izzat told you about earlier before with SageMaker. If you build the models there, you can also call that from within QuickSight and use that for predictions within your dashboards. I also want to call out the auto narratives, where you can automatically build a story around your data and around your business metrics in plain language. So what that looks like is something like this. You have a dashboard here, and the dashboard has data. And then you've got something like, oh, the daily revenue decreased by minus 0.51%, or electronics increased by X amount of dollars or X amount of percent. This is something that happens automatically. You don't need to write this anymore. You don't need to give it to a user to type it up and then embed it in the report. That's the auto part of the auto narratives. And it gives a story around your data that makes it more readable and user-friendly. So we talked about scaling your data lake. We talked about using the right tool for the right job. And now we're going to take a second to talk about why serverless is important. Now, if you use serverless services, you don't have to worry about things like patching, failover, backup and recovery, advanced monitoring. All of that is taken care of by AWS, and you just have to focus on your faster time to market, basically. Focus on building your application. Let us worry about what happens under the covers. And you build the service so that you can serve your business users and maximize your business outcomes. And we're proud to say that from an analytics perspective, we've built serverless versions of all of the services that you see on screen, and some of them are serverless by default. So you've got two options. If you have long-running clusters, you want to have maximum control and flexibility, you go for the cluster-managed versions of these services. If you want to be completely serverless and increase your time to market, you can use the serverless versions of these services. Now, you've been doing a lot of data movement now. You've been benefiting from these different analytics services. You've gotten the data to where it needs to go at the end of the pipeline. But how do you control who gets to see which data at which time? This is a very sensitive issue. The data is the new oil. You need to secure your oil, right? So if you have GDPR requirements, if you have HIPAA requirements, if you have SOX requirements, if you have CBE requirements, all of this is something that you need to manage, and you need to be able to lock down the right data assets. So to do that, you can benefit from AWS Lake Formation. Lake Formation allows you to catalog your data, tag your data assets, know who has access to which data assets in your organization. And more importantly, you can centrally define and control those things. And you can delegate access to data stewards who are responsible to assign to the level of columns, rows, or even cells, which part of which table or S3 bucket who in your organization gets access to. And it's integrated with IAM and KMS as well, so you don't need to start building a new identity provider to be able to manage your users. You can just have the roles and permissions that you already have and just apply them to Lake Formation. So you build that data catalog out and you tag the right users. That means you've democratized your data, because now any data analyst or any business user can just go into the data catalog, get the data they're looking for, and automatically the data they shouldn't see will be filtered out. So if you want to have a mental model for it, you've got your data lake and you have your analytics services querying that lake, and lake formation would kind of be like that middle layer of access control that will filter out the requests between the tools and between the lake itself. And that enables very interesting data sharing topologies for you, which have implications on your business and your data sharing agreements or requirements with other providers. So the very basic way you could set this up, you have one data lake admin and you have a centralized account and you just control from one place who gets access to the data. But the second option is to have a hub and spoke type of approach where you have different organizations accessing, or different departments accessing data from a central producer account. And in that way, you can actually manage the access from those different accounts and you can delegate access to those accounts as well. The third way you can benefit from this is to build something called a data mesh, which a lot of thought leaders now are calling, the future of data governance, where it's completely democratized and decentralized, and every data domain, we call them, owns their data end to end, and they're responsible for producing a data product that they share with everybody else. No matter what your requirements are, you can play around with these different permutations to match the exact governance requirements that you have. And if you want to take this one step further, because this really focuses mostly on internal data sharing, you can extend your data as well to third parties using AWS Data Exchange. So this is where you can literally publish your data as a product. So if you open the data exchange now, you'll see data sets from Dow Jones, you'll see data from Thomson Reuters and Deloitte. You can use their pre-built data sets with whatever way that they've allowed in terms of licensing, and start to build whatever models or frameworks or simulations you want in your environment, but you can also do the same. Once you have a data set that you think is valuable for other providers or other partners, you can upload it to the exchange and manage the commercial relationship with them, as well as the updated versions of your data sets through the data exchange. They'll log in, they'll see it, they'll pull the data, and you get an extra revenue stream, basically. We have many data exchange providers, and you, of course, can be one of them. Foursquare, Pitney Bowes, TransUnion, Equifax, and things like credit scoring, credit reporting, this becomes very important. So depending on your use case, this could be very, very useful for you. Now, the last pillar that we want to talk about in the modern data strategy is machine learning integration. Now, if you remember this slide from earlier in the day, we talk about different levels of machine learning frameworks that you can benefit from. The hardware level, where we've built specialized hardware made for machine learning problems. The second layer, which is mainly for data scientists and managing their data lifecycle. And the third, where application developers can, out of the box, use things like text transcription, reading text, reading labels, analyzing images, etc. So we've also taken those and we've embedded them in the analytics services as well, so that you don't have to keep mixing and matching all of these different tools. So across your data estate, whether you have databases, data warehouses, or your BI tools, you can benefit from having machine learning integration with them. So in your data warehouse, you could call a machine learning model. From within QuickSight, you can do forecasts or anomaly detection or auto narratives, as we've seen before. And that's something that we continue to do across our portfolio. So to summarize, to achieve the business outcomes needed for a modern data strategy, you need to have data lakes that scale. You need to have the right tools to perform analytics at scale for the right use cases. You need to be able to not spend a lot of time provisioning infrastructure and focusing on building things that add value to your business. You need to underpin these three layers with some kind of data access and security and governance. And you need to be able to embed machine learning across this whole process so that you can build or lead to that modern data strategy and become a data-driven organization. Now, we've had the honor of working on the long data journey that many other organizations have taken in the past. Organizations like Pfizer, organizations like NASDAQ, like Sling, like Comcast, like Capital One. They've all gone through this journey of, and they still do go through the journey of becoming a data-driven organization. And we want you to be able to benefit from their experience as well. And we've taken those learnings and we've taken those learnings and we've put them into programs that we can support you with on a face-to-face basis. So if you don't have a data strategy yet, we have something called Data-Driven Everything, where we can work with you to actually define that strategy for your organization and then trickle that down to a pilot where you can get things moving in your organization and have the first data product within your team so that you can push the data flywheel forward and have the first step done in becoming a data-driven organization. If your vision is already defined, we have prototyping labs where our engineers can work with your engineers, and we build an MVP or a solution architecture or some kind of artifact that can help you hit the ground running and start actually getting the data to the right people, and again, having your first step done in becoming a data-driven organization. I'm happy to take any other questions. I'll be around in the coffee area after closing. Thanks everyone for listening, and have a great day.